This is problem number 54 on the Chapter 1 Study Guide in Review. It's on page 77 of your book. And let me just work through this one with you. This is a word problem involving solving systems of inequalities by graphing. So we're told that Peyton makes jewelry to sell at her mother's clothing store. She spends no more than 3 hours making jewelry on Saturdays. All right. It takes her 15 minutes to set up her supplies, so that's like a fixed number. And then it's going to take 25 minutes per bracelet from there on out. So 25 minutes to make each bracelet. So really what this amounts to is two variables to represent the amount of time that it's going to take in order to make a certain number of bracelets. And then knowing that she spends no more than 3 hours total making bracelets. So I could define my variables as time spent, and we're going to convert this into minutes to be uniform. And X will be the number of bracelets made. So we can conclude that more time, more bracelets would equate to more time, obviously. The more we make, the more it's going to take in terms of minutes. So my system of inequalities is going to look like this. This no more than 3 hours making jewelry on Saturdays, so that's Y is less than or equal to 180, since we're going to change that into minutes to make it match the other two units. So I'm going to change my y-axis scale in 30s so I can comfortably plot 180. So that would be 180, 1, 2, 3, 4, 5, 6. And then I'm just going to draw a line. Since we don't want to go off into the negative direction, I'll just draw a line like this to represent y equals 180, and then eventually we'll be shading below that line. And then my other inequality represented is going to be this. It takes her 15 minutes to set up. Okay, we said that's just a flat. It's always going to take 15 minutes, but then the amount of time spent will depend on how many bracelets, and it takes her 25 minutes per. So we could say that y is greater than or equal to 25x, 25 times the number of bracelets, plus this fixed time of 15 minutes. All right, so let's see if we can plot. Here is 0, 15. That's our y-intercept. I'll just let x be 0. And then we can get some other points just by doing inputs. If I let x be 1, 25 plus 15 is 40, so that's another point. Still a little bit above 30. If I let x be 2, that's 50 plus 15, that's 65. 30, 60, and then just a little above. And then we'll do one more. If I let x be 3, 75 plus 15 is 90. And now I'm going to connect those. Now we'll do the shading. So if we do below the blue, which is less than, and then greater than above the red, then we're talking about this area right here. So a solution to a system of inequalities is any ordered pair that comes from the shaded region, and it has to make both of these true. Let's just take one for example. This ordered pair right here, that's definitely in the yellow, and that's 2, 30, 60, 90, 120. Okay, let's see. Well, definitely 120 is less than or equal to 180. That's definitely true. And then if we try it in the red, now remember, not only does it have to make the blue true, but it also has to make the red in order to be a true system. And so we would say 120 is greater than or equal to 50 plus 15, which is 65, and that's true. So as long as we have an ordered pair that makes both of these true, then it's a solution to the system. So basically, any ordered pair that comes out of the yellow will be a solution. And so that is your answer. That's the graph that they were looking for, and then you just have to come up with, 3 possible solutions. I gave you one. Basically, any ordered pair that comes out of the yellow, you just want to check it and make sure that it makes both of these true. If it does, it is a solution. So I hope that helps, and let me know if you have any questions.